Great, well, I think we shall get started. Looks like a great turnout. Thank you very much for coming along. Welcome along to DevOps in the Real World, a true story. It's very exciting to be here. It's very exciting to have the opportunity to share with you a whole bunch of experiences that we've had over the last 6 to 9 months or so, applying a DevOps methodology to a large piece of software development that we've been working on. Right at the very start of this project, it was completely clear that the agility that our customers were looking for, the regular delivery, just wasn't going to be served with a lot of our traditional development practices. So today I want to show and share with you a whole bunch of the things that we learned along the way. Today I'm not going to sell you on DevOps. I'm not going to talk about the business benefits. I'm not going to talk about the principles behind DevOps or those kinds of top 10 commandments of continuous integration. What I really want to share with you today are the practices and the really practical things that we did that really worked for us as we moved to this end-to-end agile kind of approach to delivering software. My name is James. I work for a little software startup based in Seattle called Zamada. I actually started with Zamada on Monday, which was a public holiday, and then yesterday I spent prepping for this talk. So I haven't actually done any work for them yet, but I do work for them. The experiences I'm going to share with you today, I haven't actually been paid by them either, so maybe I don't work for them. But yeah, I'm going to be sharing with you some experiences from my time with Intergen. I worked with Intergen for a number of years. They're a large system integrator based here in New Zealand. Prior to Intergen, I worked for Microsoft as a software developer in the States, and I worked on a bunch of products that are long since forgotten. So I'll admit to stealing a few slides for this presentation. This slide set is from Thiago and David Teaser, and they do a great podcast on Channel 9 you may not be familiar with, but it's called DevOps Fundamentals, and if you wanted to learn more about kind of the basics of DevOps, then I would very much encourage you to go in and check it out. But they have this great slide, and I couldn't think of a better way of explaining our traditional software delivery model than this. It really resonated to me, being on the dev, throwing some things over the fence, and occasionally things going spectacularly wrong when it came to operations. From a dev perspective, we've really, embraced an agile mindset, right? We can deliver features at quite a rapid cadence, but from an ops perspective, it was always a preference for stability, a preference to not disturb what's already working. So we had these kind of conflicting forces in our organization. But now our customers are expecting us to move with the agility that people like Microsoft move with, right? The Visual Studio Teams Services group ships every 3 weeks, right? If you don't look at their blog, but you should, because you can see new features coming out to this product every 3 weeks. And that kind of velocity of delivery is what our customers are now expecting. And to do that using this kind of software development model is not practical. It doesn't work properly. This isn't a new trend either. This is something that we've actually been trying to do for several years now. And I'm sorry to say that the Microsoft tool chain for the last few years has been a bit of a mess. While TFS moved to the cloud, it wasn't particularly customizable. Azure was still fairly immature. The automation options weren't great. The monitoring options weren't great. There were much better options in the market. So we've used a whole bunch of different tools over the last few years trying to head towards this goal. But I think the really exciting part is that Microsoft has now at a point where they have a really good DevOps story to tell. And it's not just VSTS, it's Azure, it's AAD, it's .NET. There's a whole bunch of pieces that have finally come together to make DevOps a reality on a Microsoft platform. So before we get too deep into this, what is DevOps? Another stolen slide. I'm not particularly artistic, so can't claim credit for this one. DevOps is a whole bunch of different things depending on who you talk to. And to be honest, I'm probably not the right person to ask for a dictionary definition of DevOps. There are lots of good DevOps talks at Ignite this week that you'll be able to attend and learn a whole bunch more about the principles behind it. But it's a combination of a bunch of these things. It's automation, it's continuous deployment, it's collaboration, it's infrastructure as code. But even I think I can recognize that DevOps at its core is not just about a tool chain. It's not a Microsoft thing, it's not a VSTS thing, it's a combination, right? And most importantly, it starts with the right organizational culture, it starts with the right set of meaningful and efficient processes, and then the tools just sit on top and make things a whole bunch easier. even within Microsoft, there are some conflicting opinions about what the right way to do DevOps are. And this is really going to be driven by your organization. You know, the culture that you have and the processes that you have and the kinds of software that you develop is really going to inform how you do DevOps. But hopefully today I'm going to be able to share with you some of the ways that we approach the problem, some of the aspects of the products that we found really valuable in establishing this methodology, and you can take what works for you and discard the rest. Now, while I can't give you details around our customer and I can't give you details around the nature of the product or the name of the product, but I can give you some kind of background. This was a web application that we worked on for kind of 6 to 9 months. It serves a global audience. It's multi-tiered, .NET based, loosely coupled through Service Bus, all running on Azure. It has a whole bunch of integration points. It uses an on-premise hybrid model. We soft launched an MVP, and then we have been dropping regular feature and bug improvements throughout the last few months. And we had a team of around 20 from dev and ops to test and project management and UX people. So not massive, but not a small project either. Right, that was actually all of my slides in one click. Thank you very much. So let's just take a moment. Close your eyes. I don't want to spoil the surprise. Right, I think that's where we were. Right, so what I was about to say before we accelerated through the presentation was don't read the words on this slide. The slide words aren't actually important. It's another borrowed slide that I really liked, and it kind of describes how we're going to talk about DevOps today. We're not really going to focus on overview. We're not going to really focus on pure practices. We're really going to focus on products and practices through today. And the way that we're going to do that is walk the whole way around the software lifecycle. So we're going to start at plan and track and talk about how we can manage our product backlogs and manage our teams effectively. We're then going to go into dev and test, spend a bit of time there talking about how do we build features efficiently and get those released. Then we're going to talk about the release process, talk about continuous deployment and automation. And then finally, we'll end up in monitor and learn and really talk about how we can get better operational visibility out of our platforms. So let's kick straight into it with plan and track. And when we talk about plan and track in the Microsoft space, we are really talking about Visual Studio Team Services. There's not really much else. At this point, Azure really doesn't come into it. .NET really doesn't really come into it. And I didn't want to make this a introduction to Visual Studio Team Services work item boards session. So what I really want to focus on here is a couple of tips that worked effectively for us, some of the problems that we had, and then move on to the next part of the software development lifecycle. And we use VSTS, we've used it for many years at Intergen, and for this project we used it right from the word go, right from the initial scoping through proof of concept through delivery. And we picked up a couple of things that we found really important to consider when moving to this kind of development methodology. The first one was to establish VSTS as the point of truth in our organization for the project status. And this is more of a cultural change in your organization than it is in a technical change. It's not hard to get data into this thing. But actually getting people to get rid of email, getting rid of Excel documents, getting rid of SharePoint lists and whatever random ways people like to store data, and actually getting this data into VSTS was a big challenge to overcome. And obviously the immediate benefits are clear, right? You have one place you can go and you can see the status of a project at any one time. But the unexpected benefit was the historical data that we were starting to capture here. And while you can use this historical data from an auditing/bean counter perspective, what we found really useful for this historical data was really for operations, right? When we were starting to capture bugs and issues and challenges that we were encountering, these things would repeat from time to time. And by using this as one central point of truth, we're actually effectively building a knowledge base for our operations team of all of the issues that we had encountered and solutions on how to tackle them. The next piece that was really important was to expect change in our process and to continually evolve our processes. One of the value propositions of VSTS, to me at least, is the fact that they ship every 3 weeks, right? There is new functionality coming every 3 weeks. So we need to build into our processes an attitude that actually allows us to go in and embrace these changes every 3 weeks. So we don't want to keep our processes fixed, design them in a heavyweight way up front. We really want to be able to adopt some of this tooling functionality to support our process improvement as we go through the project lifecycle. More importantly around process, we did our best to delegate responsibility to process away from one centralized process gatekeeper. There are a whole bunch of really cool lightweight process customization capabilities in VSTS, which I'm going to show you in just a moment. And what we found worked really well is rather than having a one-size-fits-all process that's dictated at the start of a process, is to actually empower people, individual sub-teams, individual disciplines, to be able to customize the system to work better for them. And that not only increases their engagement with the system, but also their productivity. And certainly when I occasionally went on vacation through the life cycle of a project, it was really cool to come back and actually see that the process had evolved. I didn't consider myself the process gatekeeper. We wanted to keep it as open as we could. And the last one is kind of related to the first one, and that's around reach. To get developers and testers engaged with this platform, this single source of truth, is relatively straightforward because they're going to be in it every day logging bugs or running code reviews. Getting the broader team involved, getting the UX team involved, getting the project management team involved, getting stakeholders and customers involved is a little bit more difficult. And there are some cool, pretty lightweight options that we found valuable. There are some social capabilities. There are some integration capabilities with things like Slack and other messaging platforms. And absolute worst case, if we do need to, we can use functionality that's been in TFS since it was TFS on-premise, and that's export to Excel for users that are more comfortable interacting in those kinds of tools. So, with that said, with the idea of making this the one source of truth, using process customization liberally and trying to reach our team and engage them as much as possible, let's switch over to the demo machine and have a look at a few of these in action. So this is the Parts Unlimited sample, and it's been around for a couple of years now, and there's various different versions. It's all on Microsoft's GitHub account, and they have a whole bunch of DevOps tutorials as part of the repository. So if you want to get hands-on with this stuff, any of the stuff that I show today, my version's a little bit different because I wanted to show a few different things, but it's basically the same. So if you want to get hands-on, there's a whole bunch of really good guided tutorials that can help you walk through this. So let's start with something relatively simple, and we can start with engagement. This is where we started. We started with the default Scrum template in Visual Studio Team Services. It's a very pure template, right? When you go in and visualize data, you get the very pure agile states. But for most teams, this isn't particularly useful from a reporting or a management perspective. You end up with a whole bunch of stuff in the committed column. Well, not too much, but you have a bunch of stuff in the committed column. It doesn't really give you, at a glance, the ability to say what state these work items are actually in. So let's jump into one that I've customized a little bit more. And we can talk about some of the features that we found valuable. And the customizations that you'll see here are all lightweight customizations. I didn't have to go in and log in as an administrator and reconfigure the system and then redeploy it. This isn't your traditional TFS on-premise customization. This is all lightweight customization. I haven't fundamentally changed the nature of the work items. I've just made them easier to work with. So the first thing, from an engagement perspective, there are a couple of things that we found worked really well. The first one was being able to mention people directly from within discussions and work items. And this isn't necessarily just restricted to work items, but it's also available through other artifacts in VSTS. So when you're doing code reviews, you can do mentions of people. When you start to mention people, they get email alerts. So we found really useful to engage people that weren't typically in VSTS every day. So when we wanted to reach out to our UX designers and the like, these kinds of social mentions meant that they could feel part of that process without having to constantly monitor a product they didn't necessarily use on a regular basis. The other really cool part about VSTS that we used to reach out to folks that weren't necessarily in the tool on a day-to-day basis is the feedback capability. So there's this cool option here called request feedback. And you can actually send an email message to a group of people or certain people to request their feedback. So as you're starting to head towards demo day and the end of your sprint, and you actually want to get some of that initial feedback from relevant folks, you can send them an email. And that email isn't just an email. Oh, just before I go further, this is what you get when you get socially mentioned in BSDs. You get a little link through to the product item, and you get the message that was that you were referenced in. But if we instead invite you and ask you to submit feedback, you get this email request. I haven't provided any instructions. I was a little bit lazy, but you put the test URL or something like that in there. You click provide feedback, and I was obviously rehearsing this earlier, so let me reset that. We can click provide feedback. They don't need to have any kind of Visual Studio tooling installed. No, nothing heavyweight. They just need a browser plugin. And they can click on the browser plugin and start exploring this particular feature. So I can go to my my test website, and I can use this plugin to start recording feedback directly into the system. So for example, I can do really cool things like take a screenshot. I can do things like add some notes. I can even take video recordings of my session. As I go through the site, I start to build up a little bit of a timeline, which isn't appearing here, as I add notes and visuals. And then once I'm satisfied and happy with the information that I've provided to the team, I can actually create a bug or a work item and send that straight back into VSTS. So I actually get a step-by-step list of what I've been doing, any observations, exactly what I've clicked through the workflow, my test feedback. Is it going to save? Sure, we'll save. Yeah, there we go. We'll assume that's saved. So again, this is about getting people that are not necessarily deep within the development workflow to start contributing information back in. For those that are deep within the development workflow, there are a couple of customizations that we've found to be pretty useful, and you can see some of them in action here in the board. So rather than having that kind of very static, new, approved, committed, done board, we can actually make it a lot more dynamic and a lot more useful to monitor where we are in the project. So the first one is that we can create our own columns here. So here I've split basically committed into development and pull requests and validation. So I can actually see where these work items are in the sprint. Interestingly, you can also further split this into doing and done, right? So when things are in pull request waiting for feedback, we can have those in doing and then move them into done once the feedback has been provided and they are ready to deploy into an environment that's suitable for validation. One of the things that we noticed up front, and we'll talk a little bit more about pull requests in a moment, but pull requests is one of those things that if you don't get to them quickly, if you don't actually action those pull requests quickly, or those code reviews effectively quickly, then that can be a real blocker on the momentum of a team. So we pulled that out and made that quite a high-level concept within our boards. And all of this customization is lightweight. We haven't fundamentally changed the nature of any of the work items that are represented here. So we can add new columns very easily. We can add horizontal swim lanes. So for example, in this case, we have a content team perhaps down here and a feature workflow up here. So we can actually start to separate this rather than it just being a big jumble of product backlog items. We can also do filtering directly from here. Obviously, Visual Studio Team Systems has for a long time had really rich query capabilities, but now you can actually filter directly on the board. And one thing that we've found particularly useful is being able to use, liberally use tags to be able to highlight things and then use them in our query. You'll see some color changes here. Some tags are colorful, some of the tiles are colorful. We can write rules to make certain work items and certain tags change their visual appearance so they are clearer on the backlog. So all of this is lightweight customization, but after a very, very long wait, many years, we can actually do proper customization too. So this is something if you used TFS on-premise for a long time, you will be familiar with, but there is now the ability to actually fundamentally customize your process. So you can inherit from an existing process, and this is where you can start building your own work item types. So specialist work item types, but also customize existing work items, add additional fields, relay out what the UI looks like. For example, here I've created a new work item type called ticket, just for the heck of it. And I can create the custom fields, and I can also create custom states, and I can also control whether it appears on my backlogs or not. So The really awesome part about this particular feature, which I didn't expect them to be able to provide, but they in fact have, is we can actually apply this process retroactively to an existing project. So this is not something that you need to go and do right at the very beginning of your project. You can get started, you can do some lightweight customization, then you can come along and say, actually, I am missing a work item type. Or, you know, it'd be great if I could capture this particular field on all the bugs. I can do that, and that can be applied to your project after the fact. So we have kind of a range of customization options, right? Lightweight ones that the whole team can get involved with, and this is very much on the other side where it's heavyweight. It's something that your administrators are going to need to do, but we can, in fact, get engaged with that retrospectively to existing projects. So that's kind of the high-level run-through of some of the capabilities of team management that we found useful in VSTS. Let's go and talk about the development piece. This is the bit that I find most interesting as a developer. Talk about, and I find it so interesting I've had to split it into two parts. So the first part I want to talk about in terms of dev and test is process, right? So, you know, very much, you know, how do we make our teams more effective to build and deliver features more regularly? The other part is, I've termed platform for lack of a better term, but, you know, what kind of frameworks, what kinds of technologies can we actually adopt and include in our applications themselves to make them more robust and more suitable to include in a rapid development and delivery model. So let's start with process. The first thing that we found after moving to a Git-based workflow after many years on a Team Foundation version control system is that lightweight branching is awesome, but lightweight branching can get you into trouble really, really quickly if you don't provide some kind of enterprise rigor over the top of your strategy. And what we found was that, you know, at the start of a sprint, all of our developers would go and create branches. They'd start building their features. That's exactly what you should do. It's a great way to build code, you know, small branches. But developers are naturally perfectionists, and as time goes on, as the sprint progresses, they diverge further from the master branch. They continue to work in their own little worlds. And as we get towards the end of a sprint, well, 2 days before demo day, hey, I'm done, and everything decides to get merged tomorrow. And that's a problem. Not only from the mechanics of merging, right? You know, obviously there's merge debt. There's a whole bunch of mechanical work to do there. I mean, that's not great, but it's manageable. The bigger problem that we found was that developers weren't communicating throughout the sprint, and they were making design decisions that were contrary to each other and fundamentally incompatible. So we actually ended up with a whole bunch of technical debt at the end of the sprint. So we tried to establish a rule where developers wouldn't stay away from the master branch for any more than 2 days, right? Every 2 days you were really wanting to get code back into master and share it with your colleagues. And this has a little bit of a problem, right? Because once you've merged your code into some of these common branches, you're basically saying it's ready, it's going to production. There's nothing to stop that. And we've taken a few different approaches. We've tried a few different approaches to actually resolve this problem. Some of our teams will go in and say, okay, well, I'm going to have a branch for the individual developer, and they're going to merge into a feature branch. And then once that feature is baked, that'll merge into a release branch. And then that release branch is going to merge into a UAT branch, and then finally into a production branch. That works for some teams, but that's a lot of merging. There's a lot of overhead. We tried to keep things super lightweight and really tried to avoid spending a lot of time in our merge tools. And instead had a really minimal set of branches. And the expectation on the developer was that if you are going to be checking in code and it isn't quite baked, then use feature flags liberally, right? Use a feature flag to stop this code executing until you are actually confident that it's going to work as expected or complete. So that means that allows them to continually merge into our main branches, but at the same time, it doesn't mean that code that is not quite baked reaches production. Similarly, on the other side, once the code had actually got into production, VSTS has really great traceability, so we were able to see exactly what code was running in production, and if we did need to do a hotfix, it was easy enough to branch off that particular commit. We tried to roll forward whenever possible. We found that rolling back was far more risky. For us, it was far less automated. We tried to roll forward, and if we took all of the safety checks off our continuous build and release process, which you shouldn't do, but sometimes you need to do, we could get a build out in 20 to 30 minutes. So that was always going to be a better option for us. So we tried to roll forward wherever we could rather than roll back. So from a VSTS perspective, similarly, we tried to provide a little bit of enterprise visibility over how we were doing branching and development. And in fact, we started our work items from VSTS and actually created the branch for those work items from VSTS. So from the moment the developer starts that work item, we actually have some kind of indication of where they're going to be sticking the code, right? And if they, for whatever reason, need to take a couple of days off because they're sick or they get pulled onto another project, it's super clear. I can come in, I can see exactly what branch they're working from, where the code is, and I can pick that up. So you get that visibility that probably isn't necessary for a lot of open source projects that are more distributed, but from an enterprise perspective, particularly useful. And then we can follow this the whole way through from the initial branch all the way through to the code review at the end. We have the work item and the branch tagged and associated the whole way through, so we know exactly where that code is going and where it's been. One process change that we just didn't have to make any effort on at all, and it was rapidly adopted, was using the pull request functionality that's baked into VSTS. Developers get very enthusiastic very quickly about this functionality because they like being able to share what they're doing with their colleagues, right? They like the idea of actually being able to collaborate on, best practices. So we'll show the pull request process in just a moment, but that's something that we mandated as a way of effectively code reviewing. And then the last piece is obviously you build and test on every commit. And I think at this point we should all be able to agree that there is value in continuous integration. I think that ship has sailed. I think we're all on board there. There are two pieces of information I want to share regarding the build and test piece that's available on Visual Studio Team Systems. The most recent iteration of their build service, and I totally understand if you can't keep up what iteration they're on at the moment. It does change quite a bit. But the most recent iteration of their build service, you can get a hosted build agent for around $40 US a month. Right? It's crazy good value. It's dedicated to your team for $40 US a month. So grab 1, 2, 3, 4. These are incredibly good value, and they have a whole bunch of relevant software pre-installed. It's a very easy way to accelerate your build and release process. Two things to keep in mind though. When things are cheap, they're generally cheap for a reason, and I suspect they're running on pretty standard Azure boxes, so that means disk I/O is pretty miserable. So for example, in our build and release cycle, by far the slowest component of that whole piece is npm restore, right? So when you're doing a whole bunch of disk heavy operations, you probably want to think about that quite carefully where you actually schedule those and make sure you don't repeat them. You should also be aware that they do upgrade these boxes from time to time in terms of the tooling that's on them. And a lot of the code that we write, we'll just take that no problems. There won't be any breaking changes. You won't even notice it. But sometimes if you are actually taking dependency on specific versions, you may have some surprises. You can, of course, run your own hosted build option, but I think the one that they provide out of the box for $40 is a great deal. So that's kind of from a process perspective, right? Branch smart, track everything through VSTS, adopt, embrace their hosted build options. So that's process. The other side of the fence is platform. So if we flip over to platform, you're not going to find many DevOps talks that talk about Azure Active Directory. And I'm not going to talk about Azure Active Directory as a way of authenticating your users. No, don't worry about that. Don't worry about Office 365. Don't worry about any of the traditional uses for Azure Active Directory. What we found really effective was to use Azure Active Directory within the application boundaries, right? So to represent the actors within our application, to represent how our web tier communicated with our API, which communicated with other integrated services. Right, it's all OAuth based. You get a nice kind of authentication flow through your application. And in and of itself, there's lots of ways of doing that, right? There are lots of ways of authenticating different tiers of your application. This is just one of them. But I think it's one of them that is a smart investment because of the doors that opens up later on. Microsoft has made a major investment in Azure AD. It is woven through their entire online services platform. So when you take a bet on it, it's a good bet because it opens up other doors. And one of the doors that's really cool that it opens up is that you can actually connect to your Azure SQL database using these service principles that you develop, right? So if you kind of snap to a platform that Microsoft is betting on, it's going to open up doors as you go along. So if you create a service principle for every application component, these service principles support certificate-based authentication, so you can just upload the certificate to Azure. You don't have to worry about that ever again. You don't have to worry about managing keys or passwords or anything. Once you've got these certificates up and representing your service principals, you can use that to connect to your database, and you don't have to worry about SQL auth anymore. You don't have to worry about embedded passwords that you check in, even though you know you shouldn't, but you're going to check them in anyway. It really simplifies that considerably. It also allows you to connect to services like Key Vault, right? So to go and retrieve passwords that you should be storing securely, but you've also checked those into source control because it was just easier, right? So by using Azure AD, it kind of unlocks a whole bunch of the platform. And even in the more extreme case, because Azure itself is based on Azure AD, you can start hitting the Azure APIs themselves. So your application can go in and say, actually, I want to kick off an automation job to spin up some new resources. Or, hey, I want to go in and actually query my own monitoring data. So by snapping to Azure AD, you kind of make your application part of Azure rather than something that's simply, ignorant of its hosting environment. A little bit more cloud native, I guess, for the lack of a better term. The next piece of being smart around the platform that we thought was useful was adopting Azure Resource Manager or ARM. Infrastructure as code is one of those really core DevOps principles that you'll see in most DevOps talks. It's a really important part of continuous delivery and agile delivery. Now, if you're talking about VMs, you're probably talking about things like Chef and Puppet. If you're talking about containers, you're probably talking about Docker. We built on Azure services. So for Azure services, ARM is the way to do it. And ARM is just JSON. If you're not familiar with ARM, I very much encourage you to get familiar with ARM, but ARM is basically just a JSON representation of what your application looks like in Azure. So you have a list of all the resources that comprise your application, the web tier and the SQL database and the various components. You can parameterize these files, so you can vary them by your environment, so you have a slightly different set of parameters for test versus production. One of the really important decisions we made right at the very beginning of the project between the development and the ops teams is that ARM templates were the way to do automation on Azure. So we kind of came together and said, hey, this is our common language for describing what environments look like on Azure. So we both had buy-in, we both had a way of communicating what our environments should look like, and we both had the ability to change and evolve these. So it wasn't just like a dev thing or an ops thing, it was something that we could collaborate and share. The other really nice thing about ARM templates, like a lot of good continuous deployment technologies, is they support incremental deployment, right? So I can change one little configuration value in my ARM template and then redeploy the whole thing, and it'll just apply that little change. So it allows us to have a really crisp definition of what our environments look like and avoid all of those bugs where, I forgot to go in and apply that setting to IIS in production, right? It's all of those bugs are the ones that we can get rid of by having a really crisp definition and a checked-in version of our environments. Closely related to that is the concept of configuration as code or configuration management. And it's basically as it sounds, right? You should be treating your configuration like code. You should be checking it in. You should be version controlling it. You should be code reviewing it just as you would any code change. And this is very realistic because the dev and the ops teams are now speaking the same language. Everyone knows what ARM is. Everyone can contribute and work on this collaboratively. And any kind of manual configuration steps are just not realistic at this point, right? If you're going to be delivering and releasing on a cadence like you need to, those kinds of manual steps no longer are realistic for anyone to engage in. So let's go and have a look at all of this stuff in action. Right, so let's start with code reviews. And this was a very, very easy win for our team to get started on. So you notice I've got my master branch up the top here, and I have this little icon next to it. I even have a zoom tool installed, so look at that. Little icon here. And this particular icon says that there are policies applied. So let's go and have a look at the branch policies that I have set up. So there are a number of policies that we find useful. The first one is that anytime somebody creates a pull request, we kick off a build, right? So we're actually going to merge this into the master branch. We're going to do the merge, and then we're going to build the merged version. So unless we see that build complete, you can't merge your pull request, right? So there's no bad code getting into master. Super nice feature. And that's really an example of not trying to put process in the way of developers. It's actually providing support for them automation support for them, so they don't actually have to necessarily spin up another separate dev box to validate their changes. They can actually use the automation to do this and then use their time on something more useful. We can also require work items to be linked. This was particularly useful as we were trying to stabilize the system and kind of lock things down a little bit towards our first launch to actually have a little bit more traceability of exactly what was going into the system. The last one is, whoa, it's a new feature. The last one is around code review. So we can actually require a certain number of approvals from other people in the team before code goes in. And for a long time, this is something that we've done by just sitting next to somebody else in the team and talking about the code before pressing the commit button for TFS. This is a much more formal option, right, because we can actually see the changes. I've found this is a much more useful option because everyone in the team sees every change, right? Everyone can contribute and review, and you actually, when you invest the time in a code review and you point out, for example, that your implementation of iDisposable is wrong, that's not a communication that just goes to that one person you're sitting next to. It's a communication that goes to the whole team because the whole team has visibility over this process. We do actually allow users to approve their own changes. We don't want to lock this down to such an extent that people get frustrated with the process. We want it to work for people, but we kind of set the expectation that this should be the exception. The other piece that we used was that certain parts of our code we wanted to lock down further and say that we actually needed specific people to approve specific changes in certain areas. There were some specialist areas that we wanted to have certain people involved with every review, and we can actually apply that. So we can say within certain parts of the code base we want certain reviewers, and we can just add in groups here, so as long as somebody in the group approves, then that code can be committed. So let's actually just go through that process. I made a change. Very important change last night that we'll go and have a look at. Okay, so here I am, I'm a developer, I'm creating my pull request. I give it a title, a good description. As you can see, because I created the branch from the work item originally, it's already tagged with the work item. And then I can click Create New Pull Request. So once the pull request goes up, you can see that the build is immediately queued. It's already rolling. I can then go and review individual files. I can make comments on individual files. I can do the same kind of social stuff here, right? If I see something and I'm like, oh, well, actually, I want my senior dev to look at this because I think he would have an interesting perspective, I can call him out directly and say, hey, take a look. I can even use Markdown in these comments, right? So if I'm actually wanting to say, hey, have you thought about, using async here? I can actually put, whoops. I can actually put some Markdown in line and ensure that it's formatted correctly. So there's some cool ways here to document your comments and engage people, and really share knowledge within the team. When important things are detected through a pull request process. So I'm not going to commit this. So I haven't got any approvers, the build is still in progress, the work item is linked, and at this point as a developer I'm like, well, what do I do next? There are some cool features here to enable that workflow to go a little bit more quickly. The first one is this autocomplete option that's kind of hidden, and as a developer I can say, you know what, if I get an approval and a successful build, then commit it. I don't have to come back and do anything. I just want this to go through. So I've marked that as, didn't seem to take, there we go. There we go. So it's now, as soon as everything's done, it'll get merged into master, and let me just self-approve that one. So as soon as my build completes, and it has completed, wow, that couldn't really have been timed any better. The whole thing has gone through and it's been merged. So super easy way for developers to communicate, share feedback, and effectively get good quality code into master. The other part here is, of course, the build engine. When we create new build definitions, they've got a whole bunch of great templates, very easy to get started. So I can, for example, do one that's to package an ASP.NET application up. It's not restricted to source control providers like VSTS. You can actually use other source repositories as well and use the same kind of build platform. So as you can see, it's a pretty straightforward mechanism for building a build pipeline. It's just a series of steps. The really nice thing about these steps is that there's a great library, cross-platform library, so Android, iOS, cross-platform Java library. But this is an extensible library, right? So if you actually want to write your own custom tasks to do something special with your application, you can absolutely do that. There's a whole marketplace of components that you can pull in from, or you can write your own. So if we just quickly jump into VS Code, a couple of quick points here. So here's our template that deploys all of our application, and we actually deploy this every time. Every time we do a release to production, we redeploy the ARM template just to make sure that state is maintained. We don't have any surprises in the configuration of our application. And what you can do with ARM is actually split your ARM template into a whole bunch of sub-templates. And basically this master template just references all of those sub-templates. So if I did need to deploy just a single part of my application, I absolutely could. So if I look at one of the sub-templates, I can see the website here. Deploys a whole bunch of configurations to the website, but interestingly, it also deploys the website itself, right? I actually have a component here which is web deploy, right? So it'll actually deploy the website. So it'll deploy all the infrastructure, but it'll also deploy the code to the application as well. And while it's entirely realistic for this to be part of my release pipeline, I can also run this locally, right? There's no kind of dependency to use VSTS. I can spin up my own environments as I need to. The next piece that I want to quickly show, actually before we go any further, one of the cool parts about ARM is its support for key vault. And while I can put my parameters in a parameters file, I can actually reference stuff that lives in the key vault, right? So for example, here I'm deploying a certificate. That certificate I've actually put into my key vault. I haven't had to check it in. I haven't had to do something, from a security perspective that's a little bit dodgy. I can actually put this in a secure location in Azure, a protected, audited location, and then to say, hey, grab this on the way through when you're deploying and add this to my application. So the integration between ARM and Key Vault gives you another dimension to your configuration management. Sure, you're going to check some of your configuration in, but for those secrets, you can actually leave them somewhere secure rather than having them littered through your configuration code and source control for anyone to copy and paste from. The last thing I'll quickly drop in and show is how we can actually work with AAD. So this is an example of the connection string that I use in production for this application. It's got the server name and the database name. That's it, right? So there's no username, no password, nothing. That part is completely abstracted through Azure AD. And the code for actually getting a token, and I should point that out. There's a new property on SQL connection that was added in .NET 4.6 called access token. If we have a look at how that works, we kind of have 3 lines of code to do this, right? So we create a context. We grab the cert using the cert APIs that have been around since .NET, early days, and then we request a token. Done, right? I mean, getting a token from Azure AD is very, very straightforward, especially with certificates. And that token then unlocks all of these different services that are beneficial to our application. Right. Let's keep trucking along. Cool, next part is release. And obviously, a lot of the practices we've talked about already are actually quite applicable just to normal agile development software lifecycle principles, right? Where DevOps gets a little bit more interesting is when we kind of bring in this continuous deployment aspect and the agility on the deployment to production side. One of the things that we really wanted to do was minimize the cycle, the length of the cycle between a developer checking in code and getting that reviewed to the time that it actually took for that code to turn up in a dev or a test environment. We wanted that to be a really short cycle. We wanted to support through automation as much as possible our developers to get their code in front of real people as quickly as possible. So we can set that up through VSTS. As soon as a pull request completes, it kicks off a packaging build and it releases that into our dev environment. For some of the other environments like test and prod, we want to be a little bit more managed, right? So those are going to be manual deployments. And in the case of production, we've got a few approvers that we want to have step in and actually explicitly say, yes, you may go. It's not a free-for-all. But we want to try and make sure that this is as self-service as possible and avoid having somebody with a build master hat on, as their only job. We really want to make sure that everyone in the team can do this deployment. The other part of this is testing in production, and there's this meme that's been floating around for years that says, it's the most interesting man in the world, that says, I don't always test my code, but when I do it in production. And I always thought that was a bit of a joke because, sometimes I would check code and release it, and yeah, I hadn't really tested it properly and it exploded in production. But there's actually a feature in Azure called testing in production, and it's actually a really useful feature. And it's based on the idea of staging slots in the Azure App Service. And as you can see, up in the top here. Basically, every environment, every web app that I deploy has two slots. There's a staging slot and a production slot. And the production slot is where the DNS name hits, right? This is where people go. But there's also another slot, another website effectively sitting in behind the staging slot. And that's where I deploy my code, right? So I can deploy all my code. I can make sure that the copy's finished. I can spin it up. I can validate it before I let people access it, before I do my swap into production. So that's kind of the base feature, and that's really useful just out of the box. It gives me a way. I don't have to take my website down while I do a release. I can release the staging and move staging into production. The testing in production feature is based on top of this slot concept. And rather than doing say, hey, I've got staging and I'm going to move that in production, I can say, I actually only want to send some of my traffic into staging, right? So I can say, hey, you know what? I've got a new release here. Maybe I'll say, 10% of traffic coming in, I'm going to send to this new version. Right, so 90% of the users are going to go to my old production version, 10% are going to go to the new one. And then I can use my monitoring tools to start actually validating that build. And it's a very easy kind of feature to go and adopt if you're using staging slots. So let's actually jump back to the demo machine and have a look at some of this stuff. So the really cool thing about the release management piece in VSTS is that it runs on the same platform as you build. So there's not a new kind of set of technologies to learn. It's exactly the same set of technologies. And it also runs on the same build agent we talked about earlier. So that $40 hosted build agent, you can use that to run your releases as well. So it's a really nice story to pull together. So if we create a new release definition, you'll see the process is basically the same as a build definition, right? You get a few templates, unfortunately fewer templates here. You can do things like continuous deployment based on this particular build. I can say, okay, I want to release this every time this particular build runs or not. And when I create it, I get a very similar experience, right? So I get a bunch of tasks. And in fact, I can use exactly the same tasks here, right? I can go in and build some build tasks, and I don't know necessarily why you would, but you could if you wanted to include this in your release pipeline. Down the left here, you'll see some environments, and if I actually flip over to one of the environments that I already have set up, here's my master build. I have dev, test, and production. And if you're familiar with some of the other kind of release management packages, environments here mean something slightly different. They don't actually relate to physical pieces of kit, right? You don't associate servers with environments. Environments are basically just a series of tasks that you run. And depending on the environment, you may have a slightly different set of tasks, right? For my test, I might want a little bit more validation. For my test environment, maybe the next thing after I deploy is actually I run all of my automated tests, for example. So I can customize the pipeline per environment. And if I start to find that certain things are repeated, for every environment I need to do the same 7 things, I can actually package those up into a task itself. And that's what this one here is. This release group here is actually, it's a whole bunch of smaller tasks that are packaged up, and I can now reuse that as a reusable object. And that's what these task groups are up the top there. It's just kind of a whole bunch of tasks that I package up and I can reuse through my environments. One of the other differences between our production environment here is you'll see there's a little person here. And that just indicates that there's an approval required for that environment. So before, anyone can request the build to get, the release to start, but only one person can actually allow that to go through, or one group can allow that to go through. So that's kind of the release pipeline, very similar to the build stuff. If we jump into our app itself, we can take a look at these slots. So here's my web app, just a pretty normal web app. I can jump into deployment slots here. I can actually have more than one deployment slot. I can have a whole bunch of deployment slots if I so desire. And I have a staging slot. And as you can see, it's actually a full website here, right? It has a whole bunch of configuration that is actually specific to this website. Even though it's just a slot, you can actually configure it like a website. And for example, when you actually look at the application settings, so there's some configuration here that's when you swap it into production, we'll move with it, and there's some configuration that's going to stay around. Because if you take a look at this application, there's actually a publicly accessible URL for this staging slot, right? So you can actually hit this URL and validate that it's going to work properly. Once you have these slots set up, you can go in and grab the testing and production feature, which is down here. And I can start routing traffic to my staging slot. So currently everything's going to production. I've just released a new build to staging and say, I'm not 100% confident of this build, so let me start routing 10% of the traffic. So 10% of my users will always go to staging, and the other 90% will continue to use the existing environment. So this is a really great way to go in and validate whether the build is robust, especially if you're doing like performance enhancements or some kind of things in the background. It's a really great way to actually go out and be able to say, okay, well, I've got both of them running. I can actually compare these two things. I don't have to guess whether my fixes worked or not. Right, so last section we're gonna power through. So monitor and learn. So this, from Microsoft perspective, is really all about application analytics. It starts with availability monitoring, right? That really minimum bar where you're pinging your public endpoint every 5 minutes to see that it's still actually accepting requests, right? That's the minimum bar. Then you can take it a little bit further and start running web tests, right? We can take the automated tests and actually start running them against our production endpoints. How long does it take to search? How long does it take to log in? Start to actually run some synthetic traffic through this. So that's, I think, where we start. We start with outside-in monitoring of your application, and that's something that App Insights can support. Then we can get a little bit more serious with application insights and actually start monitoring from within the application. And this is a really nice ramp, right? So we can actually monitor with application insights, applications that haven't been instrumented at all, ones that are already in production, we can retrospectively add in App Insights. We can then add in things like a little bit of JavaScript to capture browser data. We can then add in the SDK and start getting data about the application running itself. And then we can throw in at the final stage, we can actually start writing to application insights explicitly and getting data out of it. We can also, well, actually, one of the challenges that I've had with application insights for a long time is that the visualizations in the portal are pretty limited. So hopefully we'll have time just to have a quick look at a tool called Application Insights Analytics, which really supercharges this whole platform and allows us to get really hands-on with the data. We can also do a whole bunch of interesting things with Azure as a platform itself. As we move to this kind of new mindset, everyone is going to be responsible for production. It's not just the operations team. And this actually allows us to give everyone in the team access to these production environments, not necessarily with read-write permissions, but certainly with read permissions. So if I flip over and take a look. So this is a custom dashboard that I pulled together. It's not particularly interesting, but it is interesting from the fact that I'm pulling data from App Insights, from the App Service, from Visual Studio Team Systems, from SQL Database, from Azure itself. So we can kind of mash up data from a whole bunch of different sources here. If we jump into the App Insights instance, we can get some pretty standard data around performance and the like. How good our requests are. We can see what our slow dependencies are. Obviously, the database here is doing pretty well, but live.net is slowing me down. And these kinds of charts are interesting. They're going to highlight a few things to you. Where things get really exciting is this other button up the top, kind of hidden away here, called Analytics. And it's a tool called Application Insights Analytics, and it allows you to get down and query the data through basically a big data tool. So you can take all of those hundreds of millions of records you're collecting and start doing analysis over them. And I've got a couple of queries here that kind of show the power of what we can do with this. To me, this is actually the reason to use App Insights. This is actually allows me to ask meaningful questions of the data that it's collecting. So for example, here I can take all the requests I've received, filter it down to the last 24 hours, grab some percentiles of those request time slots on a 5-minute basis, and then render a chart. So I can then get this chart and understand the performance of my application over the last 24 hours. One of the really awesome features is then I can take this and pin it back to the dashboard and share it with the rest of the team. So I can actually get really specific and granular visualizations here of the things that make sense and are important to me, and then share those with the group. The other part here is an example of custom events, right? If I'm actually instrumenting my application, I can actually start querying these events, right? So I have an application event here. Every time that we bring up the order page, I have a look at the details. I can actually start pulling these pieces of data back, and I can actually parse the JSON that may be as part of that application insights event that has been logged and use that in the query. So I can actually start tracing custom metrics, pull out those custom metrics, and start doing analytics on it. It's a very powerful tool. In the interest of time, let's jump back in, and I want to show you one last feature, just to kind of complete the DevOps-like cycle. And I'm hoping I have got some exceptions here. I did try and break the application earlier, so I would. Here we go. Nice big exception here. The final feature here that I find is useful from a DevOps perspective is that I can actually take these exceptions and drive them back into the product planning cycle. So once this particular list loads, this is another reason to use application insights, because it is a little bit more grunty in its responses. You might just have to use your imaginations here, but basically I can drill into individual exceptions. I can get the usual kind of telemetry about those exceptions, but I can in fact open a work item back into my VSTS system from here. So when I see exceptions happening in production, I can actually get that straight back into the same tool that the team is using to plan their next sprint. So it's a really nice kind of full circle that I can illustrate at the end of the monitoring section. So now that we have 13 seconds left, great time to wrap up. Hopefully you've found one or two things here interesting that could be applicable to your team, that could be useful to improve how you deliver software. But depending on your organization culture and process, every organization is going to be different in the way that they approach DevOps. The one thing that hopefully you can take away is that Microsoft does have a robust stack here. So start small, start adopting some of these practices, and know that as you grow and mature in this practice, there's a whole bunch of support that the Microsoft toolchain can provide to you. And finally, to wrap up, another stolen slide, but I think a pretty cool stolen slide. So in our experience with our adoption of DevOps, we certainly got to this point. We were able to release with our ops group on a really very frequent basis. Apparently there's another stage, and I'm not quite sure what this means from a DevOps perspective, but I'll keep learning, and hopefully I can come back next year and explain what this means from a DevOps perspective. Right, I don't think we have time for questions, but I will be around at the end if you do want to have a chat. Thank you very much for attending. I hope you found it useful. I'll see you around.